In thermodynamics, we are concerned with the study of the energy of a substance. To understand the energy content of a substance, we need to study the properties of a substance. The properties of a substance can be divided into two different areas. We're going to be talking now about the thermodynamic properties of a substance. The first is the state of a substance, and the second important area would be the phase of a substance. The state of a substance is usually defined by two or more independent thermodynamic properties. For instance, the state of a substance may be described by using its temperature as well as its pressure. These are two independent properties. So two or more of these properties, like temperature or pressure, which are called independent properties, can be used to define the state of a substance. Now, when we talk about phase, most of us are accustomed to the following three phases. Solid, something may be solid, or it may be a liquid, or it may be in the form of a gas. And these are indeed phases of a substance. Water, for instance, as ice, it's a solid, liquid, water, and as vapor, it can be a gas. But these three phases are just the beginning. There are other phases. As a matter of fact, we can define 10 different phases of a substance, and we'll make a list of those right now. First of all, solid is pretty unique. There's nothing else to define when you say solid. Solid substance is just what we know it to be. But now a liquid can be categorized in one of two different areas. We can say a liquid is saturated, or we can say that it is subcooled. Now, what do we mean by these two expressions? Saturated means it has absorbed as much as it can, as much heat as it can, as much energy as it can, without turning into gas. For instance, water at 212 degrees Fahrenheit is said to be saturated. If you apply any more energy beyond this point, it changes into a gas. Now, if it's subcooled, then the temperature is less than 212 degrees. It could be fairly hot water, it could be 200 degrees, 180 degrees, and it's said to be a subcooled liquid. Now, in the gas area, we have two different categories. We'll split these up into gas. We can have one that we just describe simply as a vapor, and over here we'll put a gas. So vapor can be broken down into two different areas. We can have a vapor that's saturated. This would be like water at 213 degrees Fahrenheit. And we can have superheated. And when we say superheated, we're talking about very, very hot, much greater than 212 degrees, quite a bit warmer than that. So that would correspond to a superheated vapor. Now, under the heading of gas, we have gases that can be, first of all, we considered ideal. Now, what do we mean by an ideal gas? An ideal gas is one that is experiencing a very high temperature at a very low pressure. Because at a high temperature and a low pressure, the molecules that are in motion are so far apart from each other that the size of the molecules no longer matter with respect to anything else. They're so far apart, they're so small, that we say at this point the gas is behaving as an ideal gas. On the other hand, it may not be ideal. It might be a real gas. It may not be at that very high temperature and very low pressure. And then we can do the next thing is we can form a mixture of gases. I'll put here MIX to indicate a mixture of gases that can occur. So we have 1, 2, 3, 4, 5, 6, 7, 8 different phases so far. 1, 2, 3, 4, 5, 6, 7, 8. Well, there are a couple more that can occur. A liquid and a gas, or a liquid and a vapor, can actually be combined to form a combination we just call liquid-vapor. This is what we have with water at exactly 212. Some of it is turning into vapor, some of it is still in the form of liquid, and so we simply call this a liquid-vapor mixture. We can also have a combination of vapor and gas combining with each other to form, very simply, we call it a vapor-gas mixture. So if we add these two phases, we now have 10 different phases that could exist. We'll find reasons as we go along in thermodynamics to refer to these different phases.